Before delving further into solutions, we need to take a brief review and look at some of our various concentration calculations to make sure that we still remember the different types of terms that we talk about our solution concentrations. All right, so this should look familiar. We've gone over this earlier this semester, but our most common concentration terms are going to be our molarity, our molality, and now in this unit, we're going to be looking at mole fraction. All right, so mole fraction we use with some of our colligative properties, and then our molality we also use with colligative properties. We'll also look a little bit at mass percent and our parts per million. Parts per million and parts per billion are things we typically use in usually in more environmental contexts, because if I have something in, say, my drinking water or the atmosphere, I probably want it there in trace amounts. So I'm hoping it's in really minuscule concentrations. All right, so again, this should all be a review. So let's take a look at how we utilize some of this. Okay, so we've got some magnesium chloride. We're going to dissolve it in some water. We're going to have a final solution volume of 50 mils. Let's make sure we still remember how to do all these. And let's look at mass percent, parts per million, mole fraction, molarity, and molality. So we'll take a look at all of these. All right, so first up is our mass percent. So remember, mass percent is mass of the part over mass of the whole times 100. All right, so we'll take our 1.36 grams of magnesium chloride. We have 1.36 grams plus 47.46 grams. That's our solvent, and we'll multiply that by the 100, and we're going to get 2.79% magnesium chloride. Okay. All right, parts per million, very similar. It's still going to be mass of part over mass of whole, but this time it's going to be times 10 to the 6th. Okay, so we'll take our 1.36 grams over our 1.36 grams plus 47.46 grams times 10 to the 6th. All right, so numerically, that 2.79 should still be there, but now it's going to be a different order of magnitude. All right, so we'll get 2.79 times 10 to the 4th ppm magnesium chloride. Okay? All right, now in order to figure out our mole fraction, our mole fraction, our molarity, and our molality, we need to know moles of both magnesium chloride and the water, because mole fraction is moles of part over moles of whole. Okay, so we've got 1.36 grams of magnesium chloride times 1 mole in 95.21 grams, and we'll get 0.0143 moles of magnesium chloride. All right, and for water, we have 47.46 grams of water, 1 mole in 18.016 grams, and we will get 2.63 moles of water. Okay, give myself a little bit more room to work. So number 3, we have our mole fraction. So we're going to take our moles of part over moles of whole. So if we're doing it in terms of magnesium chloride, we have 0.0143 moles. And then I have 0.0143 moles plus 2.63 moles. All right, and our mole fraction is going to be unitless because moles over moles cancels out. And so we're going to get, let's see here, I'm going to run out of space, so I'll give myself space here, 0.00541 is our mole fraction of magnesium chloride. Now, all three of these, our mass percent, our parts per million, and our mole fraction. Could we have calculated those for the water too? Absolutely. And would we have gotten a bigger mole fraction and bigger percentages for the water? Yes, absolutely. Because remember, it's just part over whole. So if we take water to be our part, we can put that as our numerator and the whole stays the same. All right. Okay, now we'll look at our molarity. Remember, molarity is moles of our solute over liters of solution. So we have 0.0143 moles of magnesium chloride. And we had 500, or not, was it? We had 50 mils, not 500 mils. We had 50 mils of solution. It's 0.05000 liters. And we're going to get 0.286 molar magnesium chloride. All right, and then molality, it's a lowercase m. It's still moles of solute. But this time it's our kilograms of solvent. All right, so we're still going to get 0.0143 moles of magnesium chloride. And we had 47.46 grams of water, so that's going to convert to 0.04746 kilograms. And so we get a 0.301 molal magnesium chloride solution. All right, so those are some of our super common concentration terms. Now, let's say we have a situation like this where we know some information. We know that our hydrochloric acid is sold as 11.7 molar, and we have a density of 1.18 grams per mil. Can we figure out the mass percent and the molality of the solution from this information? We sure can. Okay, so remember that mass percent is mass of the part over mass of the whole. So I know that my molarity is 11.7 moles of hydrochloric acid for 1 liter of solution. And if I want the mass of hydrochloric acid, what do I do with the moles? I use the molar mass. So I can get 36.46 grams of hydrochloric acid in every 1 mole of hydrochloric acid. So there's my mass of part. I was given a density of the solution. Will that give me a mass of my whole? Absolutely. So I'll convert liters to milliliters. And then I have 1 mil for every 1.18 grams of solution. So I have liters cancel out, milliliters cancel out, moles cancel out. So I have grams of hydrochloric acid over grams of solution. Is that part over whole? Yeah. So we just do this times 100 of that whole thing. And we get 36.15% hydrochloric acid. Now that 36.15% tells me some stuff. It tells me I have 36.15 grams of hydrochloric acid for 100 grams of solution. It tells me that I have 63.85 grams of water for every 100 grams of solution, right? Because 100 minus 36.15 gives me the 63.85 because I have to add up to 100 to my whole. So that also tells me I have 36.15 grams of hydrochloric acid for every 63.85 grams of water. Now remember, molality is the moles of the solute over kilograms of solvent. So this right here will let us make that conversion. So I have 36.15 grams of hydrochloric acid for every 63.85 grams of water. Okay, I have 1 mole of hydrochloric acid for every 36.46 grams. And I have 1,000 grams for every 1 kilogram. So my grams of hydrochloric acid cancel and my grams cancel. So do I have moles of my solute over kilograms of my solvent? I do. And so we're going to get 15.53 mole hydrochloric acid. Okay? All right, so here's one that I want you to try on your own. I've given you the molar mass of the sulfuric acid. This stuff is super, super concentrated, so you get really high mass% here. I'll give you the final answers. It's 95.95% sulfuric acid and 241.5 mole. Okay? All right, so I want you to try those on your own and see if you can replicate what we did, or what I did rather, with the hydrochloric acid. Okay? That's our review on solution concentration. It's really brief because by this point, between prep chem and what we've done earlier this semester, this is stuff we do expect you to know by now. So this is just supposed to be a refresher.